All right, Crouton Ramon's House of Math. Let's do an introduction to completing the square. You have to recut a video so it will allow you to see where we're going. This is where we're going to end up, but we're going to start here. We're going to start with 5 basic concepts. Mathematics is the study of numbers. We only count stuff that's the same. We're going to form specific types of rectangles, squares, to help us facilitate the counting and make the math easy. Hero 0, no fun, get back to 1. 0 and 1, that's it. That's all we're going to cover today in this video that I'm going to make as short as possible. And you're going to see later on that, yeah, getting to problems like this, to exercise and practice, are easy and fun. But before we get to this, let's understand what we're doing. And what we're doing is making a square equal to a square. So when we first introduce this, we're going to talk about that and make a square equal to a square. Now, here's the problem. Most of you cannot see that x squared plus 2x and 1 equal to, say, 9. This is a square, and this is a square. So what I want to do is figure out what's the one side of the square, or what does x have to be in order to make this true? Well, x is two things. It's either a positive or a negative number. Because one of the things that we're going to have to know about, and we should have known about this from way before you ever laid eyes on this video, is the concept of the square root sign. So that's going to be us facilitating counting with the rectangle. All right, so again, if this is all you've ever seen in the mathematics, yeah, it's not going to be as much fun. And it might even give you a hard time. But it's not hard once you can see it. So what I'm going to do for the wee ones, and for those of you that are just being introduced to this concept of using base 10 blocks to make math super easy, make it child's play. I'm just putting a little clay on the back of my, right? Okay. Montessorians will know. Do a 3-period lesson. This is an x squared. So here's my x squared with some Play-Doh on it so it'll stick to the board. Okay. So that's my x squared. Now what? I need some x. These are x. Look, one x and another x, 2x. There's no square in there. All right, so let's put that there. And then I'm going to have to put some clay on this guy so that he will stick. Gravity, not my friend. All right. Will you stick? He will stick. Okay. Now, what's going to complete the square? 1. Oops. Make that a positive 1. There you go. All right. Now I need an equal sign because we're going to compare that. This is going to be the same thing. This square right here, because that's all we're doing. A square is going to be the same as a square. And the way we're going to do that is complete the square. So let's take it and see if I can build my square. That says 9. How did 9 get to be square? It's all round and stuff. Well, it's this. Okay, so here is 9 in a square. And I'm going to put that like right there. Yeah, I think that's good. Looks good. Okay, this is going to be problematic because it makes it hard for these guys to stick when I don't have magnets. Like I said, all my magnet stuff is in Hawaii in a storage container at the moment. Well, actually not a container, a storage unit. All right. Oh, yes, did it. Okay. Algebra. These two squares are same. The equal sign never lies. So how does this become square? Well, easily I can see that I can do a little bit of math here with this square root sign. And I can see, can I factor this? Well, yeah, this is why we factor. That this is x plus 1 and this is x plus 1. It's x. Oh, see how it is? It's x. Oh, wait a minute. Plus 1. X plus 1. And it's x plus 1 two ways. It's x plus 1 squared. That's the same thing. This and this are same. And that's the same thing as 9. Well, that makes it a little easier to see what's going on. If you know something about squares, you know that 3 squared is 9. But here's an issue. Once we square root it, there's going to be another answer too. But what if you didn't know that 2 plus 1 is 3 and 3 times 3 is 9? Well, let's do a little more math. And I'm going to use my equal sign and my square root. So let's square root this guy over here. What does that mean? That means turn it into a square, which I already did. Because I could just have, I could make a little drawing here. This could just be an x squared, 2x, and 1. Well, that's not a square. This is a square. So I take my x squared, 2x, and 1, factor it, make this, right? Because I could have 9 be like this, and that's not going to help, right? I got to turn it into a square. All right, so now I can count. And I can see, once I take my square root, okay, so this is now x plus 1. I'm just counting the one side is going to be, because this is advanced what's under the cup. That's all we're doing. 3. Now, can I play what's... And in fact, one more time, if I gave this problem to a child and made them play what's under the cup with it, they would be insulted because this problem's too easy. But I could have my cup. We'll pretend this is my cup. My cup plus 1 is the same thing as 3. Well, what does the little girl say? You got to measure. But let's do that. Well, I don't have a cup I can stick there. So since I don't have a cup that I can stick there, let's pretend that this is the cup. So I'm going to use my cup. I'm actually going to do every step so you can see how easy it is. Let's put this right here. X, and then what? Plus 1 is the same thing as 3. So x and 1 has to be same as 3. Well, can I do this? No, not if I can't get some Play-Doh stuck on it. All right, stick on there, you. There you go, perfect. Okay, so what's the first thing I'm going to do? The first thing I'm going to do is I'm going to know that there's a hero 0 over here. Can you see my hero 0? Hero 0 is going to be 1 minus 1. See it right there? There's 0. Oh, wait, let me put 0 in here so you can see. This is plus a 0, and there's my 0. Now, the equal sign says take away stuff that's same, and I'm going to see that if I take away stuff that's same, I take away that, and now x must be the same thing as 3 plus negative 1. And I happen to know that 3 plus negative 1 is 2. All right. Now here's the issue. That's only one of the answers, because this is plus or minus 3. And you'll see me do it over and over again when we start solving all of these problems. So here's the positive one, where I know that, oh, well, then it turns out that x must be the same thing as 2. What's 2? 2 is 3 minus 1. All right, so now that I figured out one of the answers, let's take a second and build this. Because now I know that this square right here, what's that square right there? Well, he's tricking you. He's trying to think that it's all big, but it's actually just a 2 square. So in other words, this square right here is a 2 square. And each one of these x's, it told you in no uncertain terms, no required imagination, that x was the same thing as 2. So this guy was trying to trick you too into thinking that he was big, but it's actually this big. Oh, so let's build this. So we're going to replace everybody, because now I know that x is the same thing as 2. Well, let's replace everybody with x being the same thing as 2. All right, so what's the first thing we should do? We should probably get rid of these guys and build a lovely 2 square. So like I said, if I had my magnetic blocks, this would go ever so much faster. But for some people, it's better because you like to go slow. And you should be playing with your blocks if you're just watching this with your arms folded, or at least drawing it. But, oh, let's put it over here. Oh, geez. Pick up the clay. How about right there? I think that'll be good. Oh, except I don't have enough clay on there to make it stick. All right. Burk. That should do it. Oh yeah, there you go. Okay, so there's my, what's that? What's this? Okay, and then what? It says that each one of them is a 2, so that means I got to put a 2. And you have the child build it. They get their hands on it, and it's not scary or hard. They see that this is what we're doing. All right, so what? I'm going to put 1 here. That's a 2. I'll put on the smooth side just so it sticks easier. But it's a 2. And this is also a 2. What's going to complete the square? That 1's going to... See, there's my x squared, my 2x. And now I complete my square. Oh, look, it's the same. Sure enough. And we can see that, what did this be? This would be 4. This would be 4 and 1. 4 in a square. 2 and 2 there is another 4. Okay, we're just counting the 9 differently. Okay, what about if it's negative 3? Well, then do the same. And we even have blocks that show the negative. And this one has clay in it. Let's get the clay out. And I'll do negative 3 now. Well, if x plus 1 is the same thing as negative 3, I'm going to skip a step just because... Actually, I'm not going to skip a step. Let's just do the whole thing. There's my negative 3 now, right? Because it's plus or minus. I still have a 1 over here, and I still have to use hero 0, because if I don't use hero 0, I can't do the problem. Nobody walks across the equal sign and turns negative. All right, what do we have? Oh, I didn't put the 1 in. I need a 1. Uh-oh. I'm missing... He ran off. He's looking for a 9. Okay, there you go. So, let's see here. Let's stick the 1 there. And like I said, play along with your child. And you can't say I'm going too fast. In fact, like I said, if you go this slow with your child, they're going to get bored. So you have to go fast. That's why we have grabbing not just a pile of 1s. We can just grab 3 3s and make this faster. And over here, now can you see? Same stuff again? Oh, same stuff again. So I take away the stuff that's same. And now I see that, oh, that's negative 4. Okay, so now what? Build a negative 4 square. What's a negative 4 square? Well, a negative 4 square is actually positive 16. I have a whole lesson on that. So what are we going to have? We're going to have positive 16. Oh, let me cover this. There's positive 16 in my square. And then what? I'm going to have 2 negative 4s. So I'm going to take away 2 negative 4s. And then I'm going to add 1. So if I took away 16 and then I took away 2 negative 4s, well, I'd have to take away that one and that one, because that's what it did. I had made the positive 16. So there's... Do I have some more 4s? I don't have some more 4s. All right. But I could put a 4 there. And look, if I take that one off, I only have 3, and I have to take 1 more. So there's 1, 2, 3, 4 that I take away, and 1, 2, 3, 4 that I take away. Oh, look, I'm back to that same shape. And then I add 1, and I get 9. Oh, look, both answers work, and they can get their hands on it and see it. Okay, 5 basic concepts. Mathematics is the study of numbers. We only count stuff that's same. We form rectangles, and in this case, not just any rectangle, a square, to facilitate the counting. Hero 0, and we didn't even have to do no fun get back to 1 on this one. All right. Once you have this much information, you should probably share this information. You should begin using it in your homeschool so that they can see the math and make it easy. And yes, we introduce algebra. Can McCrae do this? Absolutely. Can any little child do this? Yep. Can high school students do it? Yes, but they're often so damaged that they're scared. When they've got tears in their eyes, and it becomes difficult because nobody ever showed them that all we're doing is a basic concept of making a square equal to a square. And over here, this doesn't look like a square because they've never seen these guys before. But see, oh, don't get confused. This is just the same thing. I'm gonna put another equal sign. And now I can see, oh, there's that. there's that. Let's get rid of you. There's one more. Okay, so here it is. Uh-oh. Ran away. Here it is in the abstract, and there's a conversation you might have with your child. What does the word abstract mean? But this, and this same. Let's put that. I don't want a dark one. I want a lighter blue one. Let's use this one. All right, now can I see what's going to complete the square? I believe you can. So there it is in the abstract using the blocks. There it is. Oh, let's get that on frame. There you go. There it is where I do substitution, where I evaluate this expression for various values of x in the positive 3. And I didn't put my negative ones there, but you just saw it. And that's the same thing as this 9. So we know a little bit about the square root sign. We know a little bit about, oh, these blocks. They're always trying to trick you. All right. Crouton Ramon's houseofmath.com for more.